Hello students, welcome to the class. Power series representation of analytic functions. So we start this section with Lebanese rule. So this proposition says that suppose I is a mapping from closed interval AB cross CD to C. Okay, so that means we have a cross product of two closed and bounded intervals. That means suppose this is R2 and this is some AB, then this will be the closed interval AB, and suppose CD will be here, then this will be the closed interval CD. So you consider the cross products, that will be this rectangular, suppose this is B, then this will be the rectangular area. Okay, so we define a function from this rectangle region to the complex plane C. Suppose this is our complex plane C, then this function is psi of st because it is a two variable function. Right, s is varying here and t is varying here. Therefore, psi of st is a well-defined function. Okay, so we assume that this is a continuous function. Okay, now we define one more function g. Okay, g, which is a mapping from closed interval CD. This is our closed interval CD. So closed interval CD to C. So we define one more function which is from closed interval CD to C. This is g. Okay, so g of t will be here. T is a variable varying on closed interval CD. But g of t will be here. Okay, so g of t is defined by using this function psi. We will integrate from a to b this function psi of st with respect to the variable s, and we taken the limit on from a to b. Okay, this is our g of t. So since psi is continuous, which is a continuous function, we want to prove that this g is also a continuous function. You can see that this integral is well defined because psi is a continuous function, therefore which will be Riemann integrable. Therefore integral a to b psi st ds will be well defined. Therefore g of t is a well defined function. Now we want to prove that this g is continuous. Okay, moreover, if dou psi by dou t exists and continuous, in the first derivative aya dou psi by dou t exists and continuous anengil, we want to prove that g is continuously differentiable, which means its derivative is differentiable. Its derivative is continuous. Okay, and its derivative can be found by integral a to b dou psi by dou t psi of st ds. That means the partial derivative of the function psi with respect to t, then you integrate from a to b, that will be the derivative of the continuous function or the analytic function g. Okay, so which is about the theorem. Okay, so for the proof, we have psi is a mapping from closed interval AB to closed interval CD to C. So you know that closed and bounded interval is a compact set. So finite product of closed and bounded interval or compact set is again compact. Therefore this function psi is a continuous function defined on a compact set. Right? Psi will be continuous function defined on a compact set which will be uniformly continuous. Right? So I will write since closed interval AB cross closed interval CD is compact, comma, and psi is continuous, psi of st is continuous, comma, psi is uniformly continuous on the domain closed interval AB cross closed interval CD. Okay. So we are going to use the definition of uniform continuity of the function psi. Okay, so I take 2 points in this domain. So let the pair st and s dash t dash belongs to closed interval AB cross closed interval CD such that modulus of st minus s dash t dash is less than delta. Okay, then for every epsilon greater than 0, I can write modulus of corresponding to this delta, modulus of psi st minus psi of s dash t dash will be less than epsilon. Okay. Now we want to prove that g is continuous. First claim is G is continuous, right? So in order to prove G is continuous, we have to take two elements from the domain of G, that is from closed interval CD. Then when the elements in this closed and bounded interval is less than delta, difference between that two elements is less than delta implies difference between the image of that elements under G is less than epsilon. This is we need to prove. So I take two elements, let T comma T dash belongs to closed interval CD with the property that modulus of T minus T dash is less than delta. Now consider for proving the continuity of G, we consider GT minus G of T dash. Okay. So which is equal to modulus of, what is G of T? From the theorem, we have given that G of T equal to integral A to B psi st ds. So that will be integral A to B psi st ds minus integral A to B. What is G of T dash? Instead of T, psi of s T dash ds. So combining the terms, we will get modulus of integral A to B psi st minus psi st dash ds. So modulus of integral will be less than or equal to integral A to B modulus of psi st minus psi st dash ds. So this will be less than or equal to, now whatever the element S, when T and T dashes are different, the pair ST and ST dash will be different. So that their difference, since we have modulus of T minus T dash is less than delta, therefore modulus of the pair ST minus S dash, S comma T dash will be also less than delta, right? So since it is less than delta, this will be also less than delta. Therefore, by using again continuity, the uniform continuity of the function psi, I can write this will be less than or equal to integral A to B, and this is less than some epsilon ds. Actually mod ds, and this will be less than or equal to epsilon into integral A to B mod ds will be modulus of B minus A, and which is B minus A itself. So whatever this B minus A, as limit tends to, as delta tends to 0 or as epsilon tends to 0, this quantity will be tends to 0. So this can be taken as an epsilon prime. Therefore, modulus of G of T minus G of T dash will be less than epsilon. So which implies the function G is continuous. G is continuous. Okay. Now we want to prove that suppose dou psi by dou t exists and continuous, then G is continuously differentiable. അതാണ് ഇനി നെക്സ്റ്റ് പ്രൂവ് ചെയ്യാനുള്ളത്. അതായത് പാർഷ്യൽ ഡെറിവേറ്റീവ് വിത്ത് റെസ്പെക്ട് ടു ടി ഓഫ് ദ ഫംഗ്ഷൻ സൈ എക്സിസ്റ്റ് ആൻഡ് കണ്ടിന്യൂസ് ആണെങ്കിൽ നമ്മുടെ ഫംഗ്ഷനായ ജി കണ്ടിന്യൂസ് മാത്രമല്ല കണ്ടിന്യൂസ്ലി ഡിഫറൻഷ്യബിൾ ആണ്. ദാറ്റ് മീൻസ് ഇറ്റ് ഈസ് അനലിറ്റിക് എന്നാണ് നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടത്. ഓക്കെ, സോ നൗ വി അസ്യൂം ദാറ്റ് dou psi by dou t exists and continuous. So now we want to prove that. Therefore, our claim is to prove G is continuously differentiable. That means it is analytic, and its derivative G dash of t equal to integral A to B dou psi by dou t ds. This is we want to prove. Okay. So by our assumption, dou psi by dou t exists and continuous. Okay. So since psi is a mapping from closed interval AB cross CD to C, this partial derivative dou psi by dou t is also the mapping from closed interval AB to closed interval CD. Okay. Since this derivative exists and continuous, we name it this function as some psi 2. Okay, we call it as psi 2. So take psi 2 equal to dou psi by dou t. Okay, then psi 2 is also a function from closed interval AB cross CD to C. Okay, so we assumed that this is continuous function, so that psi 2 is a continuous function on the same compact set, so which implies psi 2 is uniformly continuous. uniformly continuous on closed interval AB cross closed interval CD. Okay. So whenever two pair of elements ST and S dash T dash is less than delta, we can write psi 2 of ST minus psi 2 of S dash T dash will be less than epsilon. That means we can use the uniform continuity of the function psi 2 wherever we need. Now for a fixed S in closed interval AB. So we take an element S in closed interval AB, which is a fixed element. Then you consider two elements T comma T naught in closed interval CD. Therefore, the pair ST and ST naught will be belongs to closed interval AB cross closed interval CD. This is the first set element, this is the second set elements. Therefore, these pairs are cross product. Okay. Now, if modulus of ST minus S dash T dash is less than delta, then by the continuity of the function psi 2, I can write psi 2 of ST minus psi 2 of S comma T naught will be less than some epsilon. Okay, and this will be true for every S in the interval closed interval AB. That means we can vary the elements S. Okay. Now we consider the integral modulus integral T naught to T, okay, psi 2 of S some another variable some U minus psi 2 of S comma T naught is a fixed number, fixed entry in the interval closed interval CD du. So we consider modulus of actually this term psi 2 of ST minus psi 2 of ST naught. This T ki instead I take U nu parayna variable koduthundu. You can write T also, which will be any variable, okay, T or U or anything, any term, and limit is T naught to T. Okay, so this will be less than or equal to integral T naught to T modulus of psi 2 of SU minus psi 2 of S comma T naught du. So which is always less than, because psi 2 of SU minus psi 2 of S comma T naught will be less than epsilon, because this T can be considered as U also. This the variable മാത്രമാണ് ഞാൻ ചേഞ്ച് ചെയ്തിട്ടുള്ളത്. Okay, so this will be integral T naught to T and this modulus value is less than epsilon and mod du. So we get epsilon can be taken outside, integral T naught to T mod du, that is mod T minus T naught. Okay, so we get this modulus value of this integral is less than epsilon into mod T minus T naught. Okay, now for a fixed S in closed interval AB, I define a function let phi of t. So phi of t is a function defined by psi st. This is psi, okay, psi of st minus t into psi 2 of st naught. Now I define a new function. That function is defined in closed interval AB. Okay, and that function is defined by phi of t equal to psi of st. That is function psi of st, which is given in our theorem or proposition. And psi 2 is actually dou psi by dou t ആണ്. നമ്മൾ അതിനെ പേര് കൊടുത്തതാണ് psi 2 എന്ന്, which is just rewritten as psi 2. Okay, so t psi 2 of s at the point t naught. Okay, ഇങ്ങനെയാണ് ഒരു ഫംഗ്ഷൻ ഡിഫൈൻ ചെയ്തു. Ready? Then you see what is phi dash of t, its derivative. Its derivative will become, its derivative means we are differentiating this function with respect to t. So here psi is a two variable function. If you want to differentiate this function with respect to t, that will be the partial differentiation. അല്ലേ, ഇവിടെ എസും ടിയും ആണ് വേരിയബിൾ. അപ്പോൾ ടീനെ വെച്ച് മാത്രം നമ്മൾ ഡെറിവേറ്റീവ് കാണുമ്പോൾ ഇവിടെ എന്താവും, പാർഷ്യൽ ഡെറിവേറ്റീവ് ആവും. സോ ദാറ്റ് വിൽ ഡോ സൈ ബൈ ഡോ ടി, okay, of the function st, psi of st minus, ഇവിടെ നമ്മൾ t naught is a fixed value, okay, s is another variable. So here the variable is only t, അല്ലേ, because we are differentiating this function with respect to t. അപ്പോൾ ഇവിടെ psi 2 of s comma t naught is a constant value, okay, and derivative of t will be 1. So we get phi dash of t equal to phi dash of t equal to dou psi by dou t is denoted by psi 2 of st minus psi 2 of st naught. Ready? Therefore we get phi dash of t is equal to this. Okay, and this is nothing but the quantity in this modulus. Okay, ready? Therefore when you integrate modulus of t naught to t, phi dash of t will be equal to modulus, actually dt, modulus integral t naught to t. Instead of phi dash of t I can write this psi 2 at the point st minus psi 2 s comma t naught dt. So this will be less than or equal to integral t naught to t modulus of psi 2 st minus psi 2 of st naught mod dt, and this thing is less than epsilon. We have assumed that this is epsilon due to the continuity, uniform continuity of the function psi 2. So this is less than or equal to epsilon into integral t naught to t naught mod dt. So what will be mod dt, which is equal to epsilon into modulus of again t minus t naught. So we got integral t naught to t modulus of phi dash of t dt is less than or equal to epsilon into modulus of t minus t naught. And what is this integral value? That is modulus of integration and derivative of that function phi. So by fundamental theorem of calculus, integral and derivative will become cancelled. So we got phi of t minus phi of t naught, phi of t minus phi of. So see, this integral and derivative can be cancelled by fundamental theorem of calculus, right? Therefore this integral t naught to t phi dash of t will become phi of t minus phi of t naught. Okay, phi of t naught is less than or equal to epsilon into modulus of t minus t naught. Okay, then we replace phi of t. We define phi of t as psi of st minus t into psi 2 of st naught. We replace psi of t and psi of, phi of t and phi of t naught using this definition star. So that is modulus of phi of t. Phi of t is psi of st minus t into psi 2 of st naught. Okay, minus phi of t naught. We want to replace phi of t minus phi of t naught. Okay, this is less than or equal to epsilon into mod t minus t naught. This, okay, so instead of phi of t we replace psi of st minus t into psi 2 of st naught minus again phi t naught will be psi of s comma t naught minus t naught into psi 2 of s comma t naught again. So this minus of minus will be plus here, less than or equal to epsilon into t minus t naught. Okay, so this will be psi st minus psi of s comma t naught. These two terms are psi st minus psi of st naught. Okay, minus t minus t naught into these together can write t minus t naught into psi 2 at the point s comma t naught, right? Okay, then you divide by modulus of t minus t naught. I can write it as modulus of t minus t naught. Mod t minus t naught is less than or equal to epsilon. Okay, just a positive quantity we can divide. Okay, so this will become psi st minus psi st naught divided by t minus t naught minus, this will become cancelled. So that is psi 2 at the point st naught is less than or equal to epsilon. Okay, then we integrate both sides. So we get integral a to b with respect to ds. Okay, psi st minus psi st naught by t minus t naught ds. We integrate with respect to the variable s minus integral a to b psi 2 of st naught ds will be less than or equal to epsilon into integral a to b ds. Okay, so which will be, what will be this? Integral a to b psi st is g of t. So integral a to b psi of st will be g of t. Okay, minus integral a to b psi of s t naught will be, t naught ds will be g of t naught divided by t minus t naught minus integral a to b psi 2. Psi 2 was dou psi by dou t. At the point st naught ds is less than or equal to some epsilon into integral a to b ds. So integral a to b ds will be b minus a, right? Integral ds is s, and with the limit to a to b, that will be b minus a. Okay. So what you get now? Modulus of g of t minus g of t naught divided by t minus t naught minus some definite integral will be less than or equal to epsilon into b minus a. Okay. And this will be true when modulus of t minus t naught is less than delta, right? So whenever t naught and t and t naught are near to each other, the value g of t minus g of t naught divided by t minus t naught tends to this integral. So what it means? The function g is differentiable. So which means that limit t tends to t naught, whenever t tends to t naught is less than delta, that means whenever limit t tends to t naught, the function g of t minus g of t naught divided by t minus t naught tends to this value. What is this value? Integral a to b dou psi divided by dou t with the variable st naught ds. Okay. So what is this? Which implies this limit exists. Whenever this limit exists and it is a finite value, this function g is differentiable. And its derivative g dash at the point t naught. At the point t naught equal to integral a to b dou psi the t naught divided by dou t ds. Okay. In general, what is g of t? G equal to g dash of t equal to integral dou psi by dou t st ds. Okay. And we have given that dou psi by dou t, we have assumed that dou psi by dou t is differentiable and its derivative is continuous. When it is continuous, this integral value is also continuous. Since dou psi by dou t is continuous, g dash is also continuous. So what you get now? The function g is differentiable and its derivative is this integral value, and this derivative is continuous. Therefore, g is a continuously differentiable function. In fact, g is an analytic function. G is analytic. Okay. So this is called a Lebanese rule. Okay. Now, we will solve this problem. We are going to use this theorem for solving this problem. So, integral 0 to 2 pi e raised to is divided by e raised to is minus z. Z is a complex number. ds is equal to 2 pi if mod z is less than 1. Okay. So, to use this theorem, we want psi of st, g of t, and some phi of t also. Okay. So, here take or define psi of st equal to e raised to is. This function is taken as phi of st divided by e raised to is minus z. Okay. S is variable on closed interval 0 to pi, and t is variable belongs to closed interval 0 1. Okay. Since mod z is less than 1, we have given that mod z is less than 1, right? So assume mod z is less than 1. Then psi of st will become continuous and differentiable, right? It's differentiable and continuous. Okay. Therefore, if we define g of t equal to, g of t define cheyanallo, what will be g of t? G of t was integral a to b psi of st ds. So that is equal to here a to b ആണ്. അപ്പോൾ a എന്ന് പറയുന്നത് s ന്റെ ലിമിറ്റ് ആണ് a യും b യും. So here the limit of s is 0 to 2 pi. 0 to 2 pi psi of st, that is e raised to is divided by e raised to is minus z ds. Okay. So define or let g of t equal to this function. Okay. So by previous theorem, when you define like this, g will be continuous and analytic, right? Then by previous theorem, previous theorem, G is continuously differentiable. That means analytic. Continuously differentiable. Okay. What will be G of 0? G of 0. G of t will be here. Therefore, G of s will be G of 0 means integral a to b psi of s comma 0 ds. So that is equal to integral a to b. നമ്മൾ tക്ക് 0 കൊടുക്കണം അല്ലേ? Yes. So in order to give 0 to the second variable, we define psi of st is equal to e raised to is divided by e raised to is minus tz. Then only which is a function on variable s and t. Psi of st എന്നെഴുതണമെങ്കിൽ എസും ടിയും വേണം അല്ലേ? ഞാൻ ഇവിടെ ടി എഴുതിയിട്ടുണ്ടായിരുന്നില്ല, സോറി. സോ ഹിയർ we want to define psi of st as e raised to is divided by e raised to is minus tz. Okay, so here tz, right? Then what is psi of s0? Psi of s comma 0 will be e raised to is divided by, when t is 0, this term will be 0, therefore e raised to is again ds. So which is equal to, can be cancelled, integral 0 to 2 pi, integral 0 to 2 pi ds, that is 2 pi minus 0, so that we get the value 2 pi. Okay, right. Now we claim that g is a constant function. G is a constant function. Okay, when g is a how will you say that g is a constant function? Its derivative is 0. Okay, so we will find out its derivative. What is its derivative? G dash of t. Again by previous theorem, its derivative will be integral 0 to 2 pi integral a to b dou psi by dou t, dou psi by dou t ds. Okay, so that is equal to integral 0 to 2 pi dou by dou t of the function psi. What is that function psi? Psi of e raised to is divided by e raised to is minus tz ds. Okay, so which is equal to integral 0 to 2 pi. Okay, we differentiate this function with respect to t partially. അപ്പോൾ t ആണ് വേരിയബിൾ എന്ന് ഓർക്കണം. e raised to is is a constant term taken outside. So 1 by t, 1 by e raised to is minus tz. So the variable belongs to the denominator. അപ്പോൾ 1 by t, it can be considered as a function of the form 1 by t. So what is the derivative of 1 by t? Minus 1 by t square. Instead of t, I have to write the whole term e raised to is minus tz the whole square into derivative of that function in the bracket. So that is derivative of this function means derivative of e raised to is 0, because s is not a variable here, therefore its derivative will become 0, and minus tz derivative will be minus z. Okay, ds. So this thing equal to integral 0 to 2 pi, ശ്രദ്ധിക്കാം, minus minus will be plus z e raised to is divided by e raised to is minus tz whole square ds. Okay, now we define phi of s is equal to, define a function phi of s is equal to z into I into e raised to is minus tz raised to minus 1. Okay, we define a function like this. Then what is phi dash of s? Phi dash of s means we are finding derivative with respect to the variable s. Okay, z into I is a constant term taken outside, and derivative of e raised to which is nothing but z into I or iz divided by e raised to is minus tz. Okay, so again the variable is s. Okay, here the variable is s, and which is belongs to the denominator. So which is of the form some derivative of 1 by t, that is minus 1 by t square again, e raised to is minus tz square. Okay, into derivative of this term in the bracket. So what is the derivative of this term with respect to s? So that is derivative of e raised to is only. അപ്പോൾ e raised to is ന്റെ derivative e raised to is into I, which is equal to എന്ത് വരും? I into I is minus 1, minus 1 into minus 1 is plus 1, plus 1 into z is z, z into e raised to is again, right? Z into e raised to is divided by e raised to is minus tz whole square. This is phi dash of s, right? But we found g dash of t is equal to e raised to 2 pi z e raised to is divided by e raised to is minus dz whole square ds. So what is this? This term is nothing but phi dash of s. When you define phi of s like this, phi dash of s will be this term and which is equal to this term. Therefore, this can rewrite in integral 0 to 2 pi. ഈ ടേമിന് പകരമായിട്ട് എനിക്ക് എന്ത് കൊടുക്കാം? phi dash of s ds എന്ന് കൊടുക്കാം അല്ലേ? So phi dash of s ds. So again by integral of fundamental theorem of calculus, derivative integral can be cancelled. So this will be phi of 2 pi minus phi of 0. Okay. So that is phi of 2 pi എന്ന് പറഞ്ഞാൽ എന്താണ്? phi of s. അപ്പോൾ phi of 2 pi means instead of s substitute 2 pi. So z I into e raised to I 2 pi minus tz raised to minus 1 minus phi of 0. Phi of 0 means z I into e raised to 0 minus tz raised to minus 1. So which thing is equal to z I into 1 by raised to minus 1 means reciprocal minus 1 divided by what is e raised to I 2 pi. E raised to I 2 pi is 1 minus tz minus e raised to 0 is again 1. So 1 divided by 1 minus tz. So that is equal to z I into 0. So we get value 0. Therefore, when derivative of a function is 0, that function g is constant. So when that function g is constant, it takes value, same value on its domain. Since g of 0 equal to 2 pi and g is a constant function, g of 1 is also 2 pi. ശരിയല്ലേ? g of 0 2 pi ആണ് നമ്മൾ ഓൾറെഡി കണ്ടുപിടിച്ചു. g കോൺസ്റ്റൻ്റ് ആണെന്ന് പ്രൂവ് ചെയ്തു. അപ്പോൾ g of 1 എന്തായിരിക്കും? 2 pi ആയിരിക്കും. എന്താണ് ഈ g of 1? What is g of 1? g of t is defined by integral 0 to 2 pi psi st ds. So what will be g of 1? g of 1 will be integral 0 to 2 pi psi of s comma 1 ds equal to 2 pi. Right? So that is equal to integral 0 to 2 pi. What is psi of s comma 1? We have psi of st equal to, we defined psi of st equal to e raised to is divided by e raised to is minus tz. So what is psi of s1? Psi of s1 will be instead of t we have to write 1. So e raised to is divided by e raised to is minus z dz equal to 2 pi. So this is we want to prove.